This is a video on adding and subtracting radicals, so if you want, go ahead and take notes by yourself. The reason I'm not going to spend a lot of time on this is not going to be used too often, but I did just want to go back and remind you how to add radicals. So, for example, if we have the square root of 5, square root of 5, and the square root of 5, and I'm adding together, that's 1 square root of 5, 1 square root of 5, and 1 square root of 5. That's simply 3, the square root of 5. Square roots kind of act as variables. So, for example, if I had 3x plus 5x, you would make that 8x. But if you had 3x plus 5y, you could not add that together. Same reason if you had 3, the square root of 5, plus 4, the square root of 3, we could not add them together, so your answer would stay just as it is. When I look at this example, you just want to be careful. I cannot right now add 3 the square root of 8 and 4 the square root of 2, but if I look at 8 can break down to 4 and 2, pair of 2's, so this pair, so that pair of 2's can come out, getting multiplied by the 3, giving me 6 root 2, and then plus 4 root 2, and then that would give me 6 plus 4, 10, the square root of 2. If you want to take a second and write this down. Sorry, I didn't give much time to write it down. But if I look at this, I have the square root of 75, and I have 2 the square root of 49. If you are quick enough to realize that this is a perfect square, so 7 times 2, that's going to give me a 14. And then the square root of 75, which is not perfect, so it's 25 and 3. And then I break down and it's 5 and 5, so pair of 5's come out, 3 goes back in, and then you have plus 14. That's how we leave our answer. We don't combine them. Same thing, just be careful if it was 14 plus 5, the square root of 3. Please try to remind yourself not to make that 19 root 3. Just keep it separate. And then lastly, I could give you a problem like this, the square root of 45, square root of 20, minus the square root of 18. If I look at this right now, I can't do anything because the radicals are not the same. But what you're going to want to do is break them down and see if any of them become the same. So if I did 45, I could do 9 and 5, which would be 3. So it would be 3, the square root of 5. 20 is going to be 5 and 4. Square root of 4 is 2 and 2, so that's going to be a plus 2 root 5. 18's 9 and 2. 3 and 3. So that's a minus 3 root 2. And when I look at my final answer, I want to check that 3 root 5 and 2 root 5 can go together to be 5 root 5 minus 3 root 2. And that's how I would leave my final answer. Don't put it together. You can't combine them. So that's just a quick adding and subtracting review. I did not put this on the example sheet, but I just want to show you real quick for any radical you have. For example, 3 the square root of, let's say, 6 times 2 the square root of 2, just say. I just want you to remind you that multiplication works different than adding and subtracting. Anytime you have multiplying, it's absolutely fine to multiply any numbers outside. So, for example, 3 times 2 would be 6. And then you can multiply anything in the radical. So, for example, 6 times 2 would be 12. That would be a great answer. You just want to verify that 12 can break down. So it's 4 and 3 and 2 and 2. Pair of 2's. So my final answer would be 12 root 3. So just try to keep a difference between multiplication and adding and subtracting. You cannot add radicals unless they're the same, but you can multiply radicals together at any point. All right, and then the next video will be a short video on simplifying or rationalizing the denominator.